Good morning, Year 5-6. Welcome to your maths lesson for Wednesday, the 24th of February. Arithmetic questions to start you off again. Pause the video now and attempt these. Okay, so the first one, 501 times 1,000. The digits move 3 places to the left. You get 501,000. 25% of 3,000, that's a quarter of 3,000, is 750. 7 take away 5.25 and you have 1.75. 0.5 divided by 100, 0.005. So the digits, the 5 will move 2 places to the right. So it goes from the tenths to the thousandths place. 9 take away 1.7 is 7.3. 1 3/7 take away 2/7 is 1 1/7. 422 times 24 is 10,128, and then a fifth, add 2 quarters, you might have something equivalent to 14/20. Okay, moving on to what we're doing today. So it is our third lesson of trying to find, go back to this one first, of trying to find the area of a triangle. So yesterday we learned that going back, thinking about that rectangle that we drew in the first lesson, we can actually use that to come up with a calculation that we can calculate the area of a triangle without having to draw the rectangle, basically just skipping that step, but doing the calculation as if it was a rectangle, but then doing something to the calculation which means that we're calculating the area of a triangle rather than a rectangle. And the calculation was to do a half times the base, because if you remember, what do we do with that rectangle? To find the area of the triangle, we halved it. So we're going to do a half times the base times what? Pause the video and see if you can remember what it was you multiplied by here. Okay, so it was multiplied by the perpendicular height. Perpendicular height. And the reason we call it the perpendicular height is because the perpendicular bit is very important, because the height is not just any of these three sides that you choose. It is the height, it is the perpendicular height of the triangle, which, if you remember from yesterday, is the height which comes from the base at a right angle. And we said that any side could be the base, but it needs to reach the top of the triangle at a right angle from the base. So we need to make sure that we are calculating the correct length when we're thinking about the perpendicular height. So using that calculation, see if you can remember from yesterday how to calculate the areas of these two triangles. So pause the video and calculate these. Right, so the first one, we've got 3 lengths, and if you remember the colours from yesterday, we usually had the base coloured in red and the perpendicular height coloured in green. So we've got the base here of 10 centimetres, and we know this is the perpendicular height because it goes from the base to the top of the triangle at a right angle, which is what this is here. And remember, we need to remember right angle, 90 degrees, so 2 lines which are kind of meeting at a 90-degree angle is a right angle. So we then put that into our calculation. A half times the base, so a half times the base is a half of the base, which is, the base is 10, so half of that is 5 centimetres, multiplied by the perpendicular height, which is 14 centimetres. Then we do 5 times 14. So we could do that in column. So we could do 14 times 5, or we can do 12 times 5 and then add another couple of 5s, or we can multiply it by 10 and half it. But if we just do it in column method, 14 times 5, 4 times 5 is 20. And then 1 times 5 is 5, add the 2 is 7. So we have 70. So the area of this triangle is 70 centimeters squared. Okay, and then this one, again, the same calculation. So we're doing half the base, half times the base, so half the base is 2 meters this time, multiplied by the perpendicular height. And the perpendicular height comes off the base at a right angle to the top of the triangle. So it's going to be 8. And 2 times 8 is 16 meters, and then we need to have the squared as well. So the area of this one would be 16 meters squared. Now, we had an interesting question yesterday when we were doing this at school, and the question was, what happens if the triangle is, for example, an isosceles triangle? Because none of these on an isosceles triangle, none of these sides will be coming off at a right angle. So what do you do? And we kind of said that we're kind of going to be looking at this today. So what do we do? Because not all triangles have right angles. And here we have an example of, I don't think this is an isosceles, I think it's probably a scalene triangle. All the sides are different lengths, and none of these sides meet at a right angle. And hopefully from here you can see what we do. We find the base of the triangle, but then we have to measure from that base to the top of the triangle at a right angle still, which is the perpendicular height, but that isn't necessarily going to be one of the other sides. So actually I can still calculate the perpendicular height even if it isn't one of the other lengths of the triangle. So what is the base? The base is going to be 1, 2, 3 centimeters squared, because each square is 1 centimeter square. And the perpendicular height, we go from the base to the top of the triangle. We have to go from the base to the top of the triangle. We have to go at a right angle. Now it doesn't matter that it's not one of these two lengths here. This is still the height of that triangle. So we go 1, 2, 3, 4, 5. So the triangle is 5. Let me move this over here slightly. Okay, so the triangle is 5 centimeters high. Okay, and then what we can do is purely put that into our calculation. So we do half times the base times the perpendicular height. So we do half times 3, so half of 3 is 1.5. So half times 3 is 1.5, so then we have 1.5 multiplied by 5, and we end up with 7.5. So 5 lots of 1.5, we have 7.5 centimeters squared. So even though one of these lines aren't coming from the base at a right angle, we're still going to work out what the height is from the base to the top of the triangle at a right angle. This line must come up at a right angle to work out that height of the triangle. Okay, it's still the height. And effectively, if you turned this triangle into a rectangle still, you would do it by kind of going across, see if we can do this. You would do it by going across here and then up that line there and up that line there. So we're still calculating it. So effectively, half of this, this triangle is still half of this rectangle. These two spaces here, if you combine those two together, would be the same area as that triangle in the middle there. All right, because you can see this rectangle is still 1, 2, 3, 4, 5 centimeters high, even though it's not one of these lines. That doesn't matter. It's still 5 centimeters, and you can see that even with the rectangle if we think back to yesterday and the day before. All right, so have a little think for yourself now. Which arrow is the base? Which arrow is the perpendicular height on this triangle? So pause the video and have a think. Which line is which? And there are 4 lines for you to choose from. So pause now. All right. Now the base. Which arrow is the base? Now, if we said this was the base, this line down here, because it's at the bottom, then this would be the perpendicular height. Now you can kind of see that that could be correct because it goes from here and it goes then measures to the top of the triangle. And as long as that's going at a perpendicular line, then that's absolutely fine. But we've got the base here, and we know that then the height, we know that that's a right angle, from that line there up to there, because we've got the symbol here which shows it as a right angle. So we'll say this is the base, and then the perpendicular height is this blue line here, going up from the base to the top of the triangle at a right angle. So with these ones, we also want to label the base of each triangle and label the perpendicular height. So pause the video again and see if you can decide which lines are which is the base, which is the perpendicular height. Pause now. All right, so which one is the base? So if we look at this one, we can see that this line down here is the base, and the perpendicular height will be this line here. Has to be this one because it is coming from the base at a right angle, and it is in line, it goes to the top of the triangle, is how high that triangle is. And this one over here, which line is the base? This 8 centimeter line here is the base. And then which line is the perpendicular height? It's this one coming up through the middle here, because it is coming from the base to the top of the triangle at a right angle. So there is our perpendicular height. And then we could work out the area. So we would do half the base multiplied by 3. So half times 4, so half of 4, which is 2, times 3. So the area of this triangle would be 6 centimeters squared. And then with this triangle, the base is 8, so we do half of 8, which is 4, multiplied by the height, which is 4, so the area of this triangle would be 16 centimeters squared. So have a little go. Could you work out the areas of these triangles? So pause the video again and work out the areas of these ones. Okay, let's have a look. So what calculation are we doing? Or what steps are we following? So step 1, identify the base. 2, identify the perpendicular height. Then step 3, you want to complete the calculation. So step 3 is a half times the base times the perpendicular height. Perpendicular height. There we go. So step 1, the base. The base is this line here. And then the perpendicular height is going to be this length here. So we want to do half the base, half times the base, which is 4, multiplied by 11 will give us an area of 44 centimeters squared. And then this one, we know that the base is 3. But we know then that the perpendicular height comes from the base, and with this one it's been extended a little bit, extended from just to make the base a little bit longer, but we're not actually changing the length of the base. We're just following on the line as a guide to see where the base is so that we can reach the top of the triangle from this length here. So we could go from in the middle here and calculate it and go straight up here. It doesn't have to be done this way, but we could go from here, from the base, as long as it goes up at a right angle. It doesn't matter where this line starts, it's still going to, I'm going to be able to change this now, no, it still goes from the base here, as long as it goes to meet in line with this line here, that is always going to be the height. It doesn't matter which point along the base you measure it from, as long as you measure it at a right angle up to the top, that is how long the triangle will be, or that is the height of the triangle. So then we do half the base, the base is 3, so it'd be 1.5 multiplied by 7, and you get 10.5. All right, time for you to have a go at some questions now. Following those steps, following that calculation, and then attempting these ones. So pause the video and have a go. Okay, so let's have a look at some answers. So silver, the area of this one, we've got a right angle triangle to start us off with. So it was half the base, which was 6, so half the base would be 3 times 5, and then the area would be 15 centimeters squared. Here we've been given where the base is, and the height here, the perpendicular height, half the base would be 3 multiplied by 5 will be 15 again. And then B's down here, so we've got another right angle triangle. So it doesn't matter which one you said was the base, so you could have said this one was the base. So it would have been 5 times 7, or you could have done 3.5 times 10. Either way, you're going to have 35. And then this one, half the base, so the base is 7, so it'd be 3.5 times 10, which is going to be 35 again. And with these ones over here, again, we've got the base and then the perpendicular height. Half the base will be 4 multiplied by 5 is 20. With this one starting to, let's do this one first down here. So half the base will be, so here's the base, so half that would be 6 multiplied by 5 will be 15. So 3 times 5 would be 15. And then this one, it's trying to now make us think a little bit more. It's giving us 3 lengths, and we need to make sure we're really clear on which length is the base and which length is the perpendicular height. And hopefully you were able to realize that for this to be the perpendicular height, this cannot be the base, because this line is not coming from this line at a right angle. This angle round there is definitely not a right angle. So what we have to say is that this line is the base, this 4 meters here, because the length coming up, the height coming up from here is at a right angle from this base. So we say this is the base, so half of 4 would be 2, and then multiply by 6 would be 12. And again, 3 lengths here. We've got our base has to be this line here, because this 6, although coming up from the base, it's not coming up from the base at a right angle. It's this line here which is measured the perpendicular height coming from the base. So it'll be 1.5 times 5 is 7.5. Right, now some gold questions for you to try and tackle. The area of each triangle is 12 centimeters squared. Find the missing length. So you've got to work backwards. So the area is 12. What does that mean these lengths must be to make it 12? Remember, the base has to be halved to multiply it by the perpendicular height. So think carefully about what you're going to be multiplying after you've halved the base to solve this one. And with this one, class 6 are calculating the area of this triangle. Here are some of their methods. Which ones are correct? So you're not going to tick them. Just write down which ones are correct and explain any mistakes. So pause the video now and do these questions. Right, so you needed to make an area of 12 for both of these triangles, which means this length had to be 3 on this one. Why? Well, you might have got confused and maybe made the mistake that you put 8 times, you didn't put 8 times 3 here, because 8 times 3, hang on, doesn't make 12. But remember, you had to half the base first. 4 times 3 does make 12. So although this says 8, actually when you're finding the area of the triangle, you half it first, don't you? So half of 8 is 4, multiplied by 3 would be 12 centimeters squared. And with this one, you're thinking, 12 times 1 is 12, so it's got to be 12 here. No, because remember, you've got to half the base before you multiply it by the perpendicular height. So you've got to effectively double whatever the length was going to be here to then half it afterwards. So the full length is 24 centimeters. Then you would half it to 12, then multiply by 1 to have 12 centimeters squared, which means this length started off, well, it always is, 24 centimeters. All right, and then this one, which ones were correct? So the correct methods are 16 times 2 divided by 2 and 4 times 8 divided by 2. All the other mistakes are due to not choosing a pair of lengths that are perpendicular. So the importance of choosing the perpendicular length. Exploring other methods to get the correct answer, e.g. halving the base first and then calculating. And we talked yesterday about multiplying them, then halving. and it doesn't matter which way around you do it in the end. Platinum time. So we've got a few slightly more abstract questions, but it's the same principle. All you've got to do is think about what is that calculation? Half times the base times the perpendicular height. So pause the video again and try the platinum questions. All right, so the shape is made up of 3 identical triangles. What is the area of the shape? So you needed to find probably the area of one of them and then multiply that by 3 to find the area of all of them. Each triangle is 6 centimeters by 11 centimeters, so the area of one triangle will be 33 centimeters squared, which means the area of all 3 of them would be 99 centimeters squared. How do you know that? Well, if you halved this, you would have the length of the height of that triangle. Let's say we're finding the height of this triangle. We know that from here to here is 11 and 11. So we know from here to here is going to be 11 centimeters. And we know that the base is going to be half of this here. So from here to here, the base will be 6. And the perpendicular height will be 11. So then we can use that to calculate the area of one triangle. All right. This one, the diagram shows a shaded triangle inside a rectangle. What is the area of the shaded triangle? So what do we need to know? We need to know the length of the base, and we need to know the length of the perpendicular height. So where is the base? The base of the triangle we can say is here. What is the perpendicular height of the triangle? Well, we need to measure from here up to here, which is from the base at a right angle to be in line with the top of the triangle. And we know that that is 6 centimeters. So we've got the information we need to calculate half the base, which is 2, multiplied by 6 is 12. It doesn't give units, so we're not sure of the units. Oh, yes, it does, centimeters. So it'll be 12 centimeters squared. And then this one, similar kind of problem to the other two, really. The diagram shows 4 identical shaded triangles in a rectangle. The rectangle measures 36 centimeters by 24 centimeters. Calculate the area of one of the shaded triangles. So it's very similar to this one, actually, in the way you would have tackled it. So thinking kind of what's half of this, and then that would give you one base here, and then you could calculate up to here would be the perpendicular height, and that would be half of the 24 coming up here. Then you do half the base multiplied by the height, and you would have got hopefully 108 centimeters squared. So that's the end of finding area of a triangle for a while. It's something we may come back to, but we're going to carry on with area. In the next lesson, we'll be looking at the area of, I think, a parallelogram. So it's something to look forward to in the next lesson. Well done.